Hey guys, so in this video we're going over Unit 2 test review. Like I said Friday, we're going to start where we stopped on Friday. So we stopped pretty much at number 7. So for number 7, we are creating tables for each of our equations, and we're going to include our restrictions. So for example, the first step, we're going to include where x is -3 because we have to know where we put our open circle. We have to know where to put our closed circles for step 2, and we have to know where we put our open circle for step 3. So let's create our tables. How we create our tables is we go to our calculator or to Desmos, we go to y equals, and we type in our step 1. Our step 1 is -3 raised to the x. Once we do that, if you're using your calculator, you're going to go to second graph to go to the table, and you're going to go where x is -3. Again, we're going to x is -3. No, x cannot equal -3, but we have to know where to put our open circle. So for our first step, x's, our y's, our first x value that we're going to include in our table is -3, and our y is -0.037. This is going to be our open circle. Then we want x values that are less than -3. So our next one would be -4. And our y value when x is -4 is -0.0123. So then we need to graph it. So let's go to our graph. I'm going to make it a little bit thicker. So 1, 2, 3, 4, 5, 6. So there is our x and our y axes. And we're plotting -3, 1, 2, 3. It's going to be right underneath it, and this is going to be an open circle. Then our next one is -4, -0.0123. So right over a little bit. And we're going to go over. So this would be our graph for step 1. For step 2, we have absolute value bars of x, and then the restriction of -3 to 1. So we're going to create our table for second step. Our x values and our y values. So we're going to go back to y equals. If you're following along in your graphing calculator, you're going to clear out that first step. You're going to go to math, go over to number, and find where it says abs. It's the first option under number after you hit math button. So you're going to select abs, and that gives you your absolute value bars. And you're going to put an x in the middle of the bars, and then go back to second graph to get to your table. So for this one, a graph of absolute value looks something similar to this, where it creates a V. Well, if you're creating a V and you want x equals -3, x equals -1, you're going to have to include where that V changes directions. So in this one, we have to use more than just 2 points so we can actually see the shape of the graph for step 2. So we're going to start where x is -3, y is 3, so -3, 3, and then we're going to keep going down, or keep going up because x can be greater than -3. And when does it change directions? So our y values are going 3, 2, 1, 0, but then all of a sudden when x is 0, y's go back up. So it goes 3, 2, 1, 0, 1, 2, 3, so on and so forth. So that is where I want to highlight where it's going to change directions on my graph. And then we're going to x is 1, so x is 1, y is 1. Now, it so happens that on step 2, we have closed circles because we have or equal to on both restrictions, both sides of the restriction. So we're going to have closed circles at -3, 3 and 1, 1. So let's graph this. So we have -3, 3 on our graph. It's a closed circle. Oh, nope. -3, 3. And then our second point was 0, 0. And then 1, 1. Biggest thing to remember, so if you had only gone to x is -3 and x is 1, you would have only had these 2 points. And then you would have thought that the equation would give you a straight line. Well, it doesn't. It gives you a V shape. That is why you had to include 3 different points for step 2. You do not want to miss out on that V shape. Then step 3, we have x plus x squared. So our third step, x, y values. So we're going to go back to y equals. You're going to clear out that step 2 and type 3 plus x squared. Second graph, to go to your table, you want where x is 1, so you know where to put your open circle. So that's 1, 4. And then you go above or greater than 1. So 2, 7. So you're going to graph this. 1, 4. And this is going to be an open circle because there was not an or equal to. So it's an open circle. 1, 4. 1, 2, 3, 4. Open here. And then 2, 7. So 2, 7 would be somewhere up here. And it would keep going that way. So this would be your graph for number 7. There you go. It looks something like this. Alright, so for number 8, we have to evaluate our piecewise. So we're given 3 different values. All of these f of 2, f of 20, f of 25 is telling us what our x value is. So for number A, it is telling us that x equals 2. So we're going to go to our steps and asking ourselves, looking just at the restrictions, is x less than 16? If it's true, that is the step we're using. So 2 is less than 16. Yes. So we're using this first step. So when we go back to our A, we're substituting it in. So 1 minus, instead of x, we've got 2 plus 3 times our x, which is 2 squared. And we're simply going to type it into the calculator. 1 minus parentheses 2, close the parentheses, plus 3 parentheses 2, close the parentheses, squared. And you get 11. Now you can type this into Desmos and it gives you the exact same. Desmos does act like a calculator, a regular calculator, as well as graphing. For B, we have x is 20. So we go to our steps, or go to our restrictions. Is 20 less than 16? No, it is false, so we don't use step 1. Is 20 greater than or equal to 16? Yes. Is 20 less than 24? Yes. So this is true. So this is the step we use. If you're not really comfortable at deciding which step to use, keep going. Make sure that that is the only step that is true. So third step, 20 is greater than or equal to 24? No, it is not. That is false. So you would not use step 3. So we're having to use step 2. So we've got 4 times our x is 20, minus 1. If you don't like doing mental math, you can use your calculator. 4 parentheses 20, close the parentheses, minus 1, equals 79. And that would be your answer. And then lastly, we have C. C is telling us our x equals 25. So we're going to come back to our restrictions. So we're asking ourselves, is 25 less than 16? No, so we can't do step 2. So we got 16 less than or equal to 25. Well, is 25 greater than or equal to 16? Yes, but in step 2 we have 2 parts of our restriction. So the other part is 25 less than 24? No, so this is false, so we would not be using step 2. Step 3, 25 greater than or equal to 24. Well, 25 is greater than 24, so yes, this is true. So we're using step 3. Step 3 only has 3 as the equation. There is no x to plug in 25, so the answer is simply 3. What this is saying, kind of to visualize this, is the actual equation goes y equals 3. Well, if our x is 25, our y is 3, so our answer is 3. Anywhere on the equation y equals 3, does not matter what x is given, our y is always 3. That is why the answer is what it is. Alright. So we've done 8. Let's go to 9. 9. Clayton Booster Club is selling candy at all Clayton High football games. The Booster Club is planning to buy the candy from Jim's Candy Store. For the first 50 pieces of candy, Jim charges $1.25 per piece. If the Booster Club buys between 50 and 100 pieces, Jim will charge $1.15 per piece. If more than 100 pieces are bought, Jim will decrease the price to $1. So I'm going to color code this. I'm not going to do it individually. I'm just going to go straight to the piecewise. So let's do blue for our first step. Now let's set up the outside of our piecewise. So let's use blue for the first part, the first step. For the first 50 pieces of candy, Jim charges $1.25 per piece. So $1.25 times however many pieces there are. And this is only for when x, or the number of pieces, is less than or equal to 50. So that would be our first step. Our second step, if the Booster Club buys it between 50 and 100 pieces, Jim will charge $1.15 per piece. So $1.15 times however many pieces are sold, and this is between 50 and 100. Well, 50 was already included in step 2. So we've got 50, and we've got our X can be greater than 50. It can also be less than 100. So in between, does not include 50 or 100. And then we've got our third step. If more than 100 pieces are bought, Jim will decrease the price to $1. So $1 times each piece is sold, and that is when X is greater than 100. Now, you have to use kind of your common sense. Third step says more than 100 pieces. So the third step cannot include 100. So that means that for our second step, we have to include 100 in our second step. So I'm going to zoom in so you can really see it. So $1.25 times X when X is less than or equal to 50 is our first step. Second step is $1.15 times the number of pieces of candy when X is greater than 50 and less than or equal to 100. And then our third step is $1 times however many pieces that we're buying when X is greater than 100. So that is going to be our piecewise for number 9. So for B, on number 9, we have how much will a Clayton Booster Club have to spend if they want to buy 143 pieces. So we're going to come in here and ask ourselves, which step is 143 in? So step 1, is 143 less than or equal to 50? No. So second step's restriction, 50 less than 143. Is 143 greater than 50? Yes. But is it less than or equal to 100? No, it is false. So we cannot use step 2. Step 3 is 143 greater than 100? Yes. So this is the step that we're using. We're using step 3, which is $1 times however many pieces we're buying. So for B, we have $1 times our X, which was 143. So we're having to spend $143 on candy if we want 143 pieces. Alright, so then we go on to 10. 10 says, for a cellular phone billing plan, $35 per month buys 250 minutes or less. Additional time costs 25 cents per minute, and this is worded incorrectly. Minute over 250. So that is changing our equation when we create that second step. So we're going to first create our outside of our piecewise. So we are told our equation is C of X equals, and then our squiggly. And then I think what's showing up a little bit better is darker colors. So let's try darker colors. Let's see if the blue works. Let's see, navy works. So $35 per month buys 250 minutes or less. So we're going to include 250 and then or less. So we've got $35 as a flat fee, and that is when X, or the number of minutes, is less than or equal to 250. And then let's try burgundy. So the additional cost is 25 cents per minute over 250. So this is going to make our equation look a little bit different. So we're going to have our $35 plus our 25 cents times our minutes over 250. So we're going to have 250. Nope, we're going to have X. Subtract our 250 that we've already paid for. And that is going to be when X is greater than 250. So this is our piecewise. So then we're asked, how much will you pay if you want 300 minutes? So you've got to ask yourself at which step. So is 300 less than or equal to 250? No, that is false, so we don't use step 1. Step 2's restriction, 300 is greater than 250. Yes, that is true. So we're using step 2. So we're plugging it in, or substituting our X in, and that 300 is our X. So 35 plus our 25 cents. Our X is now 300 minus 250. We're substituting that in, and we're typing it into our calculator. So 35 plus 0.25, parentheses 300, subtract 250, equals 47.50, but we're talking about money, so I'm going to put a 0 at the end. So it's $47.50. It's what our cell phone bill would be if we needed 300 minutes. All right, for 11, we're asked to find the linear regression, the quadratic equation, regression, and the correlation coefficient for both in between A and B. So what we have to do first, and it was on your notes for your regression notes, go to second, 0 to go to your catalog, and then go down to where it says diagnostics on. So arrowing all the way down, or you can just click D and find it. You have to hit enter once to select diagnostics on. Then you have to select enter again to turn it on. Diagnostics is not on until it says done in the answer place on your calculator. So then you're going to go to stat, edit, and put in your values. So for this one, our X values are your temperature, and your Y values are your number of cans sold. So in your L2, you're going to put 340, 30, all of your X or all of your Y values. So once you have all of your Y values in, you can go over to L2. No, it does not matter what order you do these in. I just so happened to be on L2 first. Went over to L1, cleared it out by hitting clear and narrowing down or hitting enter. And I'm going to put in all my x values, so 56, 64, 64, 68, 70, 75, 80, 84. So now I have all of my values in. I can go to stat calc because I'm going to calculate something. In linear regression, for linear regression, it looks like under stat calc for line reg a times x plus b. So that is what you're selecting for linear regression. Once you hit that, before you hit enter again, you're going to go talk to Mr. Vars. If it looks like the newer ones where you have store reg equation, you're going to go to the store first and then go talk to Mr. Vars. So select Vars, talk to Mr. Vars, ask why Mr. Vars is my function wrong. So you're going to go arrow over to where it says y vars and select function underneath it. So hit enter again and again. And then you get your A, your B, and your correlation coefficient. So my A, and I'm going to do this really small so I have enough room to actually write the equation. So your A should be 17.97174,784. Again, I put way too many decimals on my sheet just to make sure you know what the value is to check your rounding. Yes, I will take off of rounding if you round incorrectly. So we're going to put these in our linear equation. If you don't know your linear equation, it's y equals ax plus b, or what we're used to is that a being an m. Don't ask me why the calculator uses an a instead of an m. I guess it's easier for the calculator. Then we're going to substitute our a and our b in. So we have y equals 17.97x minus, because our b is negative, 745.3. And I'm just rounding where I would round it if I was you guys. And our correlation coefficient, r squared, is 0.9164. So we do have to put our correlation coefficient, which is our r squared. Then we go on to B. B is using the same data. We're just going back to stat calc and selecting quadratic regression instead of linear regression. So we're going to go stat calc, and we're going to go down to number 5. Our quadratic regression looks like this under stat calc. It's 5 quad reg. So that looks like that on our calculator. So our A, when we select that, before we get our A, B, and C, we're going to go to the store, or we're just going to go to VARs. Ask why Mr. VARs is our function wrong. Enter until we get our A, B, and C. So our A is 0.452. Our B is negative 45.773. And our C is 1,468.66. And remember, your quadratic is y equals ax squared plus bx plus c. So we're substituting those a, b, and c's in, and we get the equation y equals 0.45 x squared plus So it's not going to be plus because our b is negative. So subtract 45.77x. And then plus our c because it's positive, 1,468.66. And then our r squared, just reading it off the calculator, don't have to do any extra steps for it, is 0.9609. So there are my equations for A, B, and we have to have our correlation coefficient for both of them. So for C, with the regression model that fits best, how many cans will be sold when the temperature is 97? So I only want to look at my R squares. So only looking at 0.9164 versus 0.9609. Well, which one is closest to 1? The quadratic correlation coefficient gives us closer to 1, so that is the one that we are going to use. Now, it's very important that you do not just type in the equation that you rounded to write down. There's a lot more decimals involved. So what you must do is go back to Stat Calc, go down to number 5, select it, and store the equation with Mr. Vars if you haven't done so already. Under y equals, that gives you all of the decimals that you need to calculate when x is 97. Again, do not just substitute 97 into whatever equation you rounded for in B. So we're going to go to second table to find where x is 97. Well, I don't want to scroll all the way to x is 97 because I'm all the way at x is 12. That's going to take too long. So you go to second window to table set, and you set your table to 97. Then you can go back to your table by going second graph, and it starts the table where x is 97, y is 1,281.5. So that would be the number of cans that you would have for C. And that would be 11. All right. So for number 12, we have a similar situation. We have to find the power function or the power regression line or model. So this one, we're going to go back to Stat Edit. And we're going to clear out our data from number 11. So in L1 is our x values. So 1, 4, 5, 7, 9, and 11. And then L2, we're putting our y values. So 3, 20, 67, 168, 69, my bad. 345 and 400. So then we're going to go to Stat Calc because we're calculating something. We're calculating that power function. So we're going to go all the way down until we see power function. Power regression function under Stat Calc looks like this. It's option A, and it's PWR RG for regression. So that is what it looks into the calculator. So we're going to select it. Again, if it's the newer one, we're going to go down to Store Reg and go talk to Mr. Vars. If we don't have the newer one, We're just going to go talk to Mr. Vars before we hit enter again. Go talk to Mr. Vars, ask why Mr. Vars, is my function wrong, enter. So my A, let's see if blue shows up. My A is 2.2497. My B is 2.138998. So I'm creating my equation. I'm substituting my A and my B in to the equation y equals A times x to the B. So I would get y, I cannot see that. I'm sorry, guys. Let's try red again. Y equals our A, which was 2.25 times x raised to the 2.14. So that would be your equation for A. B, it says use your model up from part A to estimate the y value from y value when x is 6. Again, do not just plug in x is 6 to the equation you rounded in A. You have to use the equation with all of the decimals in your calculator. So because we talked to Mr. Vars, it's already there for us. So go to y equals, it's there. So we go to second graph to go to our table. We're going to find where x is 6. Now, if you're following along, your calculator is just exactly where mine is. It's at x is 97. I'm not going to scroll all the way up to where x is 6. I'm going to make my calculator do all the hard work. So I'm going to go to second table to go to table set, and I'm going to set my table to start at 6. Once I set it at 6, I can go to second graph to go back to my table. When x is 6, y is 103.89. Now, that is my predicted. The reason why it is my predicted is because my regression line from A gave me that number. The actual data, or the actual y values, is what's given. I had to find that 103.89, but what is given is the actual. So when we get to C, our y equals 120 is actual. It's actual. So when we find our residual is our actual points, subtract our predicted points. So in this situation, our actual was 120. Our predicted was 103.89. So we put that in our calculator. And we get 16.11. And that is our residual for when x is 6. All right, 13. 13 through 15, we are determining if it's even, odd, or neither. So we are only looking at our exponents to determine if it's even, odd, or neither. So I am looking where our exponents are. We've got 2 and 6. 2 and 6 are both even. So this function is even. 14. Well, I only see an exponent of 5, but what's also understood in the exponent? A 1. the x has an understood 1 in the exponent. So we're comparing 5 and 1. Well, both of them are odd. So 14 is odd. 15, we are comparing the exponent of 3 and the exponent of 2. Well, 1's odd, 3 is odd, and 2 is even. So it is neither even or odd. If there's a mixture of even and odd exponents, it's neither. So then we're done for 13 through 15. So then we go to our min and our max. Min and our max, we're just graphing it. So we can use our graphing calculator to make it calculate it for us. Or we're going to use Desmos. So let's use Desmos. Okay. So let's go to the internet. We've already got Desmos set up for us. So we're going to type in our equation. So the first one was y equals negative 3x plus 2x squared. So y equals negative 3x plus 2x squared. Now our x squared, we cannot, or for squared, we can simply just hit a squared. That gives us our equation. Great thing about Desmos is that if you hit the line, it gives you 3 gray dots. And then you just select that minimum, and there is your minimum point. So we are not just putting 0.75, we're not just putting negative 1.125, we're putting the whole thing. A minimum or a maximum is the location of your min or max. It is not just a value, so you have to create the whole ordered pair. So your answer for 16 would be 0.75, negative 1.125. So that would be your answer for that equation. And no, it does not ask you, but if you want to, identify the fact that it's a minimum, not a maximum. All right, 17. 17, we have the equation y equals 7 minus x minus 2x squared. So we're going to put that into Desmos. So we're going to select that box. We've got y equals 7. I'm sorry, I'm not remembering. So was that 7 negative? No, okay. 7 minus x minus 2x squared. So that gives us our graph. So we gotta come out some to actually see it. Now, are we gonna have a min or a max? We can pinpoint our max, or our biggest point, our highest point. We cannot pinpoint our lowest point. So we do have a max. We're going to hit the line or select the line, and our maximum is our highest point. The other 3 lines that show up in Desmos, so when you select it, the line that is on the y-axis is your y-intercept. The other line, or the other point that shows up, is your x-intercept. So Desmos does a lot for you. But in this situation, we're only worried about our maximum point because we have a max, not a min. And we have negative 0.25 and 7.125. Again, you're putting the whole ordered pair. have negative 0.25 and 7.125 as our answer. So there is 13 through 17 with the answers. And this is the time of the video. If you got what we went over during class Friday, then you can stop watching. But if you didn't or you were absent, then you can keep watching. So we're going to go back to number 1. For number 1 through 3, we have f of 0. F of 0 is telling us x equals 0. So we're going to go to our graph and figure out where our point is when x is 0. Well, when x is 0, y is also 0. So that is the only point when x is 0. 0, 0 is my ordered pair. So my y when x is 0 is 0. So my answer is 0. Number 2, this is telling me x is 2. So what is y going to be? Well, I'm going to go to my graph. I'm going to figure out where my x value is 2. So this is talking about this line right here where x is 2. Well, there's not a point here. It's not included, so this is not a point. So I'm only looking at this point. Only looking at this point here. I'm coloring in. So at this point, the ordered pair is 2, 3. So when x is 2, y is 3. For number 3, it says f of 3. So f of 3 tells me x is 3. Finding what y is. So coming to my graph, x is 3 is this vertical line here. The only point on this line is here where I'm coloring in. And at this point, the ordered pair is 3, 3. So x, y, so when my x is 3, y is 3. Something that I pointed out Friday is the fact that I don't care if you set it up like this or write this part out, as long as you have 0 as number 1, 3 as number 2, and 3 as number 2 and 3 as number 3. Right. Number 4 tells us to write the piecewise with the restrictions. So we're first going to write the equation separately, and then we're going to put it all together for a piecewise. So for our horizontal lines are going to give us y equals some kind of number. So that's going to be, because if we look at our first step, this line that keeps on going, doesn't matter where I am on this line, my y value is always 4. That is why all of the horizontal lines are y equals whatever y value it goes through. So for our first step, it's going to be y equals 4 because it crosses the 4. Then we have to create our restrictions. I suggest on the test to not write in pen so you can erase it. So now we have to create our restriction for step 1. Well, our x stops at x is negative 2. It can equal to, because there's a dot, a closed dot, when x is negative 2. So we have or equal to. Now my x values can be less than negative 2, not greater than negative 2. So x is less than or equal to negative 2 for step 1. All right, for step 2. Step 2 is another horizontal line. So we have y equals whatever y value goes through, which is 2. We got to create the restrictions. So we have x starts at -2, and it goes all the way to +2. It cannot equal -2, and it cannot equal +2, so we do not have any or equal to in this step. The x values can be greater than -2, so the inequality is going to be x is greater than -2. If you need to, draw the little teeth. X is greater than, so the alligator teeth are going to be eating the x. And then according to x is 2, x values can be less than 2. So x is less than 2 is our restriction for step 2. Step 3, let's try blue. So our step 3 is crossing where y is -3. So our equation is going to be y equals -3. Our restriction is going to be it stops where x is 2. So x can be greater than 2. And it can also equal x is 2 because it's a closed circle. So once we've created all of our equations and our restrictions, we can create our piecewise. Do not leave your equations and your restrictions like this. If it says write the piecewise and you leave it like this, it is not a piecewise. So you did not answer the question. So we have f of x equals our squiggly. First step was y equals 4, so it's 4. Restriction was x is less than or equal to -2. Second step was y equals 2 with the restriction of -2 is less than x and also less than 2. And our third step was y equals -3 with the restriction of x is greater than or equal to 2. So there's our equation for A. What are the end behaviors? Biggest thing, if we're asking for end behaviors, how many arrows are in our graph? 2. So there's only going to be 2 end behaviors. So for the first arrow was in our first step. So as we move it to the left, so as our x values go to -infinity, our y values are going to 4. It's staying at 4. So we have an behavior for our first arrow, x going to -infinity, which is to the left. Our y values are going to 4. Then we have our second arrow. Our second arrow is going to the right. As we move to the right, so as our x values go to +infinity, which is the right, our y values are going to be going to -3. So that is our end behaviors for number 4. So number 5. Number 5 says write the piecewise with the restrictions. So we're having to create piecewise again. Our piecewise, all of these are linear. So before we go into how to create them, always remember your y equals mx plus b, where your b is your y-intercept, your m is your slope. So we have to have an m and we have to have a b when creating these equations. So right now in step 1, we do not have a b. So we're going to extend it. We're going to extend it all the way till we hit our y axis, and it's intersecting it at 4. So for step 1, our b is 4. Our m is going to be our slope. So we have a point here, and we have a point here on our line. So we're going to go up 1. So going up 1. And then to the right 1. So because we went up and to the right, our slope is completely positive. So we have 1 over 1. So our equation is going to be y equals 1 over 1 times x plus 4 because it was positive. Now we want to erase everything we did for step 1 on our line, not our equation that we just created. So we can create our restriction. Our x is going to stop at -4. So x -4. Can it equal -4? No, because we have an open circle. And then our x values can be less than -4. It cannot be greater than -4. So x is less than -4. All right, step 2. Step 2 is the easiest one because we already can see where we intersect our y-axis. And again, if you can't read these numbers, assume it's by ones. So if you can't figure out that that intersects at 5, you've got 1, 2, 3, 4, 5. So our b is +5. Our slope, well, here's a point at -1, 3, and another point at 0, 5. So you could use the equation to find your slope, or you can count it on the graph. So we went up 2, so up is +2, and to the right, which is +1. So our slope is 2 over 1. Again, up or down is the numerator, and left or right is the denominator. Rise over run. So our equation is y equals 2 divided by 1 is 2 times x plus 5 because it's positive. Now I'm going to erase everything I have on the line for step 2 so I can create my restriction. My x's start at x is -4. So I have -4. My x's can equal -4 because it's a closed circle. And my x values are going to be bigger than x is -4. So the little alligator teeth are going to be eating the x. And then they're going to stop when x is 1. And then from x is 1, they can be less than 1. So x is less than 1, and it can equal 1 because there's a closed circle. So our restriction is x is greater than or equal to -4. And x is also less than or equal to 1. That is our restriction for step 2. Now I'm going to erase some so I can focus on step 3. Step 3, kind of like step 1, we do not know what our y-intercept is. It is not 2. It is not intersecting all the way over here. That's 2 different lines. So we've got to extend it. And we can see that it intersects at +3. So we have b equals +3. Our slope, well, here's a point on the line. Here's a point on the line. So we're going to go up 1. So going up is positive. But then we're going to go to the left one. If we're going to the left one, it's negative. So our slope is going to be +1 over -1. Our equation is going to be y equals positive 1 divided by negative 1 is negative 1 x plus 3 because it was positive. So I'm going to erase everything on my line so I can really see my restriction. My restriction starts at x is 1. So 1, and my x values are going to be bigger than x is 1. And then it cannot equal x is 1 because it's an open circle. So there's no or equal to line. So then I'm looking at my biggest x value. My x value for step 3 is stopping when x is 4. My x value can equal 4. And from x is 4, my x's are less than 4. So x is less than 4. So once I've finished all that, I can finally create my piecewise with my restrictions. F of x equals squiggly. I've got my equation for step 1 as y equals 1 over 1 times x plus 4. 1 divided by 1 gives me just 1. And 1 times any number is just itself. So I have x plus 4 as my first step, with the restriction of x is less than negative 4. My second step, I've got 2x plus 5, and I've got negative 4, x is greater than or equal to negative 4. You can put commas in between if that helps you. Less than or equal to x, and then it can equal 1. Just rewriting what I've already written because it has to be put into a piecewise for it to be correct. Negative 1x as my first part of my third step. Do not have to put the 1, but I do have to put the negative. And then I've got 1 is less than x, less than or equal to 4. So there is my piecewise. So now I have to create the domain and range. And remember, it's going to be worded for the whole piecewise. So we're going to keep going to the left forever and ever and ever. So this is going to keep going forever and ever and ever. So our smallest x value is negative infinity. And then we're going to come all the way over here where our third step is. And our biggest x value is going to be found at that 4. X is 4. And because it's a closed circle, we're going to include it. Our range is our y values. Now, this is the trick. Yes, as of how it looks, our smallest y value is in step 2, where y is negative 3. But our step 1 keeps going downward forever and ever and ever. If it keeps on going down forever and ever and ever, we have a smallest y value of negative infinity. And then our tallest x value is in second step at y is 7. So we're going to go all the way up. It's a closed circle, so 7 is included. So there is 5. All right. 6 is our last one. 6, we're having to graph it again. So we're going to use Desmos this time to find it. Step 1 is very, very easy. You don't even need a calculator, hopefully. You don't even need Desmos, hopefully. If we have a function f of x equals 4, or the same thing as y equals 4, that means that there's going to be a horizontal line where y is 4. Always. Doesn't matter what the x value is. So for our first step, when we create our table, all of our y's are going to be 4. And then we want where x is -3, because that's going to be a closed circle. And we want x values that are smaller than -3, so -4, -5. So let's create that table, or let's graph that table. So let's make it a little bit thicker line. 1, 2, 3, 4, 5, 6. So I cannot draw a straight line, you guys know this. But there's our y-axis. 1, 2, 3, 4, 5, 6. From the top is our x-axis. So there we go. So -3, 4. Forward. And that's going to be a closed circle. And then we have -4, 4. And -5, 5. And we could keep going. No, you do not need 3 points on this one. You just need 2. We're going to keep on going to the left forever. So we're going to have an arrow pointing to the left. So there is our graph for step 1. Step 2 is a little bit more complicated, so you may have to put it into Desmos or a calculator. Second step. Let's use Desmos for this time. So x plus 1 is a linear equation, so we do not have to have more than 2 points. So we want when x is -3 and x is 0, so we can connect the two open circles. So let's use Desmos, x plus 1. So clear out our quadratic that we had and type in y equals x plus 1. So here is our graph. We want exact points to graph, and we want where x is -3. So either you can see it, or you can drag your pointer over it to where x is -3, y is -2. So -3, y is -2. And this is an open circle because we don't have the or equal to line underneath our inequality. And we're looking where x is 0. So again, you can drag your finger where x is right there. When x is 0, y is 1. That's going to be another open circle because there's not an or equal to line underneath the inequality. So I'm going to graph this, -3, -2, open circle, and then it was 0, 1, open circle, connect the dots because it's linear, we only had to worry about 2 dots, and there's our graph for the second step. Our third step is also linear, so we're only worried about 2 points. So our third step, x value, y value, we We've got negative 3x minus 3, so we're going to use Desmos. If you need to know how to use it in the calculator, go to the other example on the review. So we're going to clear out what we had, and we're going to type in our new equation, y equals, what was it? Negative 3x, okay. Negative 3x minus 3. So there is our graph. We want 2 points. And we want where x is 0. Gotta go all the way down. Again, you can type it or click on the gray dot because that's giving you your y-intercept. So 0 is negative 3. So that's one of our points. And then another point when x is greater than 0. So let's zoom out some and figure out where. And I'm going to look for a whole number, not a decimal. So 1, negative 6 is another point that I can use. So I'm going to graph this. And when x is 0, it is a closed circle because we have the or equal to in our third step. So 0, negative 3 is here. And then 1, negative 6 is roughly here. So that line's going to keep going forever and ever and ever. So here's your answer for number 6. And that should be all of them. If you have any questions, remember to email me and I'll try my best to answer them from home.